Math 3 geometry homework. So to help you out with this, you'll want to go to the shodor.org website. I want to say it's interactive/activities, and then / there's one that's the one for this two-dimensional cross sections. I think you can search from a list. It's like the cross-section flyer. And the other one I want to say is, I think, transmogrifier. That one I can't look at, but it's the one we did in class. So anyway, using that is a great way to help take a look at what these two-dimensional cross-sections would look like. So that's what I would suggest doing, is going to that website, taking a look at that, playing around with it, and doing all of these first. Like the first two would be the cross-section flyer. The last ones would be the transmogrifier. Okay, so once you're done doing that, then come and take a look and see how well you did. Okay. Other than that, if we're talking about a right cylinder, if we do a horizontal slice, that's going to give us a circle. A vertical slice actually ends up making a rectangle. A diagonal slice that doesn't go through the base gives us an oval. If it goes through the base, then it kind of changes and has a flat part, so it's more like a semicircle look. And that's what you should have gotten for the right cylinder. Okay, square base pyramid. So a horizontal slice would give us a square, because that's its base. Vertical slice through the vertex opposite the base, so that would be a vertical slice coming straight down from here up to the vertex. That actually gives us a triangle. A vertical slice not through it would give us a trapezoidal figure, so trapezoid. And 7, a diagonal slice through all 4 lateral sides on the base and the base. So for that, it would probably look something like, let's see, this one's hard to see, so you'd like start kind of going through the base there, and then you go up, and then it would go across the other ones, but it would basically give you a pentagon shape. Alright? Okay, right rectangular prism, horizontal will give us a rectangle. A vertical will give us also a rectangular piece, so rectangle. A slice that cuts off a corner, which we know a corner is the wrong word, we should probably say vertex, would give us a triangular shape, so a triangle. And then a diagonal slice through one base and all of the lateral sides. So we'd kind of have to come here and go down to the base like that. And that looks like it would give us a rectangle, possibly a square if you had it just right. Unless we needed to get to that side too, didn't we? So maybe let's try that again. That one's hard to visualize. I'm going to have to finish this. I'll go through everything else we can look at. We'll have to look at that one through the website so we can figure that one out a little better. Okay, sphere, horizontal. It's a circle. A vertical is also a circle. And a diagonal would be a circle too. For a hexagonal prism, a horizontal would be a hexagon. A vertical would be a rectangle. We're going to probably need to use the website to finish those ones as well. We'll come back to those ones when we're done. Okay? Now let's do some rotations. And using the website is the best way to really see that, because it just is harder to visualize on a two-dimensional piece. So, rotate this around the y-axis. So this would make a circle, that would make a circle there, so we get a cylinder. Okay, around the x-axis, we still get a cylinder, but it's just a different one. Slightly different shape. Okay, around the x-axis, we get a smaller, squattier cylinder, but cylinder nonetheless. Now what about this triangle? This actually ends up giving us a cone. Okay, around the x-axis, we get another cone, just in a different shape. Okay, around the y-axis here, gives us kind of like a cone, but more like just a 3D parabola, which I'd probably call that a cone that's, doesn't have a vertex. It's a rounded cone. Call it that. Okay, this one around the x-axis would give us a cone, just a squattier one. This one around the y-axis would give us a cone shape. Not exactly, because it's not straight, it's curved up. But that's kind of a similar, different style of cone. Okay, number 9 around the y-axis. This one would actually go around like that. Just think of it this way. So this would be circular. It would almost be like a very similar to, I think, a stadium maybe. Might be good. Kind of the opposite of this one. It's like the negative space there around that one. So, not sure what you would even call that. And number 10, that would just give us a sphere. That going around that circle. Okay, so I think what I'll do is when I get back and I'm able to, let's just use the website and I'll take some screenshots and we'll be able to kind of see all the different pieces so we can get this down better. Alright, so I went back and using the website took all these pictures, so I'll put them on and we can talk about those to make sure you understand what it actually would look like. And going to those websites would be a great one to use to help you figure it out too. So for question 1, 2, and 3, so if it was horizontal, it would make that circle cross-section. Vertical would give us a rectangular cross-section. And if it didn't go through a base but was slanted, it would give us an oval cross-section. Okay? So that's what they should have looked like. That visualization is probably much easier to see than me just trying to explain it. So let's take a look at the next ones. So with our pyramid with a square base, okay, a horizontal, that gives us a square essentially, same, or rectangle. I guess it's more rectangular. If we go through the vertex down through the base, that makes us that triangle. If we don't go through the vertex, it cuts it off and we get a nice trapezoid there. Then if we go through the base, then up through the 4 lateral faces, okay, it gives us a pentagon there. Okay? Now looking at these guys, let's take a look at the rectangular prism. I'll actually have to use a cube, but it should give you the same kind of thing. So looking at this, I had to use a cube, but it's essentially a rectangular prism. So this would give you an actual rectangle if it was rectangular, or it still could give you a square. Okay, this one here would give you the same idea, a rectangle or possibly a square. Here, when we cut off that vertex, which is what they mean by corner, we see we get a triangle. And then if we go through the base up here, and through each of the lateral faces. It's kind of hard to visualize, but it's cutting through up here, over here. We end up with a pentagon again. Yeah. Okay. Now the sphere, I decided not to do because I can't get a sphere on here with the cross section, but they're essentially always going to be circles because it's a sphere. Okay. Now a hexagonal prism, we've got those ones. So with our hexagonal prism, horizontal just gives us a hexagon, vertical gives us a rectangle. It's that diagonal going through the base that we want to see. Okay, so because we go through that base, that creates one side, then we have all these other lateral sides here to make that, and we get a 1, 2, 3, 4, 5, 6, 7, 8. We are able to actually, did I do a 6-sided or a 7-sided figure here? 1, 2, 3, 4, 5, 6, 7. Oops. So you actually would have only been able to get with a 6, with a hexagonal prism, you would have only been able to get a 7-sided figure. Okay, because we can't get this bottom base involved unless we could somehow, so it went through all the pieces. That would be the only way, because each of these faces would represent an edge or a side of the octagon. So to answer that last question about could you do an octagon, you'd have to be able to go through the base, then go through the lateral sides, and there's 6 of those, so you'd have to somehow be able to get it to go through all 6, and so then it would come up and also go through the base, giving you the top and the bottom for those 8 pieces. So if we can do that, we could get that last one. Alright, now we'll take a look at these rotations here, kind of the same way. So we've got the first 2 around the y-axis and the x-axis, just that square. So hopefully we can see around the y-axis it creates that cylinder this way. Around the x-axis it creates that same cylinder, but just the vertical orientation. Okay, notice that we've got a cylinder and not a prism. Okay, 3 and 4, now that we've raised this up or done a triangle. So notice it makes another cylinder, but it's got a hole in the middle of it, whereas a triangle makes us that nice cone. Okay, now these last ones. Okay, so a triangle still makes a cone, just a different orientation. Now that quadratic one, I tried to do the best I could, and I think I did a pretty decent job, but it kind of looks just like that. It's like a rounded cone, essentially. Okay, that's what we see there. Now 7 and 8, we've got this kind of swoopiness, so let's see what those give us. So we can see from these, it's kind of just that curved cone. Okay, it's just going to be that curved kind of cone shape. Okay, so 9 and 10, let's see what those ones look like, and we'll be done. Okay, for 9 and 10, 10 easy, it's just going to be a sphere, but 9, it's got that shape inside here that's unused, essentially. It's hollow, and then we have this other one. So hopefully those helped you guys visualize a lot better, and there we go.